Hello everyone, this is lecture 382. So we'll go for the RCC estimation or schedule of RCC reinforcement that we have to do. So in this lecture we will try to explain you how the bars will be used, and if it is bent, how much extra length will be taken. So if you suppose take a standard hook, then one end is bent, then L plus 90. L is, this can be outer length to this way L, you can B calculate. So total length will be L plus 90. Now if you take the bent up both sides, then L plus 18D. This L you will calculate, and overlap can be taken at 48D to 45D. If you bend this bar, alternate or you build both sides, so bent up bars, if you bend the bars, so what will happen, if it is bent 45 degree, so the additional length will be L, you can calculate sin 45 D upon L, hypotenuse. So hypotenuse and L equal to D sin 45, that is D by 0.07. So this length is there, but this is the actual length. So this will be this length. If you take the length L, so this length is added, but the difference to be added so that this bent up can be adjusted. So for this additional length will be, that is hypotenuse minus base minus D. So D upon 0.0702, this value minus D, that is D minus 1.07. So this will be your approximately 0.707. This will be your 0.07. So 0.42, this is taken 0.45D. So the extra length will be taken in L. L will be L plus 0.45D if one bend. If two bend, L plus 0.45 D into 2. This will be length. So this will be, you can say L. This can be L. Plus extra, if bent up is there, you can L plus 9D or L plus 18D, you can add. So for that you have to take the precaution. If it is bent up, bar is bent up at 45 degree, then you have to take 0.45D extra length. If both sides bend, then this will be 4.45D into 2. This is approximately 0.42, so this is rounded out and taken as 0.4. If you bend at 30 degree, then sin 30 D by L equals to 2D. Now this base will be how much? D by base sin 30, we get D by sin 30, which is 1.73D. So the difference additional length is 2D minus 1.73, that is 0.27D. So this is approximated 0.3D. So if you bend the bend, the length will be L, one bend 0.3D extra, this will be L. If two bend, single bend, this is single bend. If both is bent, then L plus 0.9D, 3 into 3. 3 into 2, that is 0.6D. Extra will be added. So this will be length, only this length, you can say this length. If it is bent, then this length L will go for 0.45D for one thing, or this will go L plus 0.9D, or this will go for 30 degree, this can be L plus 0.3D or L plus 0.6D. So you have to take in mind that this will be done like this. So we can start some problems, and that is bar bending schedule. You can say bar bending schedule, please go through. And so whatever you do in the drawing, you have to take the precaution, or if you have bent at 30 degree or 45, extra length will be taken. So for a slab, you can say if any slab is created like this, slab is there. So what will happen? This is, suppose this is 30 centimeter wall. This is 30 centimeter wall. We just taking this thing, what is 30 centimeter wall. So if you cover the half cover, this center line, the 15 centimeter, this is your 15 centimeter. So this distance is your, if you suppose this is 4 meter and this is your 3 meter, clear. So this distance will be your 4.30 and this will be, if you take 10 center, this will be 3.30. So what will happen if you take this thing, we can have 0.30. So your reinforcement will come from, if you start from here, you can say, so it is going like this, it bend L by 4 to 5 and go like this. This will be like this. So what will happen if you calculate the whatever be the thickness of the slab, maybe say some thickness of slab. So bar is here, suppose the bar is here and you bend up like this and go like this. So the distance, that is D, that is depth, you can say depth, clear cover, you can say, that is clear cover. So this will be your, whatever be the difference of the you can say difference of from top to bottom layer, you can say. So this will be deducted overall depth of slab, you can say, or beam minus bottom cover minus top cover. So this will give you the D, that is D. You can say this is D, this is D, this D. This D is nothing, that is cover from top and bottom, overall depth of the slab is deducted. So D overall depth of slab are D minus bottom cover and top cover. So whatever cover, if you are providing 20 mm cover, so this will be your 20 mm cover, you can say 0.02, 0.002, 20 mm, 0.02 into 2. This will be deducted from the, if suppose 120 mm cover is there, so you will get deduct 40 mm, 20 mm from the side. So D equals to your 80 mm. 80 mm is your D. In this way, you have to calculate the D. So with the help of this thing, we'll try to make the bars, bend a bar or something like that. Reinforcement bar schedule we can calculate. So in this lecture we have just given you the idea how we will calculate, and we will take the example in the next lecture to calculate the total reinforcement, total length of the reinforcement, and the estimate of reinforcement can be calculated. Thank you for being with me. Thank you very much.